Hello, everyone. How's everybody doing? Hope you're doing fine. Better than me, I hope. Anyways, today we're going to have a little chat. I'm going to be covering, reviewing a little bit, summarizing really what I said about the flat people, the flat universes, the flat um Earths, and also the plane Earth, right? And then I'm going to move on to the electric universe. I'll be discussing them today, specifically uh, very low volume. Hello, hello, hello. Can you hear me? No, it should be okay. Maybe I'm just talking to myself. Can you hear me now? Is there a problem with the volume? Anyone? Let me know. Uh huh. I don't know what to do. I've got it at maximum volume. Yes, you can hear me? Hello? You can't hear me. Okay. I don't know what's going on. The equipment I think is running okay. I'm checking all the uh, controls here, and I think I'm doing okay. I don't know. Some of you might have a problem. I don't know. The mic may be too far. Well, let's bring the camera a little closer. I don't know if that's the issue. Okay, I'll try to speak up. Okay, sorry about that. I hope. Okay, I don't know. I've got it all set up right as far as I know. Okay. Anyways, uh, yeah, I got it a little closer. Okay, just wanted to, just incidentally, I just want to mention something since it's the subject matter today. Some people may not know, but some of you have heard of Wal Thornhill. Some of you have heard of David Talbot. They are the leaders, you could say, the head honchos of the electric universe. And just want you to know they've been friends of mine on Facebook for many years, 8 to 10 years, I think. I don't know, but it's been a lot of years that they've been friends, and they know all the stuff that I say about them. Okay, so I think they're aware of a lot of stuff that I say. Now I think they're fine people. No issue there. But here we talk about theories, okay? And one thing to keep in mind is when you attack a theory, as polite as you want to make it, no matter how polite you are, what you're saying essentially is that the other person is an idiot. That's what you're saying. Because you're criticizing his theory, that means he's not being rational in the way he thinks his theory. And so you're implying it anyway. Imagine a Christian telling you, oh, yeah, I believe in God and that Jesus went up to heaven, came back. And you say, oh, okay, that's nice. Well, he knows you're bullshitting him. he knows he knows that you're thinking something else and saying what you're not thinking. So I think you should put the cards on the table and just say it like it is. Stop beating around the bush. Forget about being too diplomatic about it. Let's just lay it on the line. If the guy has an irrational theory, you should tell him that he's got an irrational theory. And that if the implication is that he is irrational, that he's not thinking right, well, I'm sorry, so be it. That's life. So I don't apologize for that. And again, it's not a personal attack. It's just that if their theory is irrational, it follows that, well, you're insinuating or more or less thinking that he's irrational too. Okay, and I don't think there's any escaping that. Okay, anyways, to turn his volume on. I don't know what to do about the volume. The volume is at max. I have no idea what the problem is with the volume. Some say it's fine, some say it's not fine. I don't know. I don't know what to do. Okay, whatever. I'm going to continue. For those who can hear me, otherwise you got to turn your volume up. I don't know. I don't know what's going on. Okay, I'm looking at everything. Everything checks out okay here. Okay, okay. Anyways, let's get on first with the flat earthers. By the way, like I said last time, you got two groups, at least two groups. There's more than two groups for sure. One is the flat earthers, and the other one is the plain earthers. And these are dissidents of those dissidents. They don't get along. They have different ideas. So you shouldn't confuse them. They have different theories of gravity, and that's what I want to go over with one more time. Okay, so this is their model. Okay, this is the model they proposed for the Earth. Okay, I covered that last week. Okay, and what you have is the sun and the moon rolling around the perimeter of the Earth. Whether they move this slow or this fast, I don't know. But one thing for sure, something is wrong in the sense that the moon should be below the sun because that's the only way that you can get an eclipse. Okay, if you're looking at it from the bottom up, the only way you're going to get it is if the moon gets in front of it. Of course, that's for the solar eclipse. Now, when it's a lunar eclipse, well, I don't know how they do it. Then the sun has to get behind the moon or something. I don't know. Or I'm sorry, in reverse, the sun has to get in front. So yeah, eclipses are going to be a problem with them, and that's one of the problems. What is their mechanism for gravity? Well, it looks something like this. They claim in their site that essentially there is something called dark energy. I put dark matter. It's the same thing. Um, you have all this dark energy, dark matter that you cannot prove, okay? That's underneath the flat earth, pushing it up, okay? Up, whatever up means to them, okay? So they can't peek below there because they can't get to the edge of space because it's guarded by soldiers or who knows by whom. And what you have is um, all these particles. I don't know what else to call them. I put particles because I think that's what they're referring to when they say dark energy. It's an unknown form of energy, as they say, pushing it up. Okay. Now, one fellow he had a good reply, which I liked. I want to share it in case you haven't read it already. He says, when they propose that flat or plane Earth is moving up or whatever, some seem to forget that the observed motion is not constant but undergoing acceleration. That's important. It's an acceleration. Remember, gravity is acceleration. If they're going to explain acceleration, that the apple did not fall on Newton's head, but that the ground pushed Newton up towards the apple, we're talking about a constant acceleration. And like he says here, that means that the flat or plane Earth is reaching ever higher speeds as it keeps constantly accelerating. Good comment. If you stopped Earth's acceleration in their model, you would have to explain quite a lot of the consequences. The question then becomes, since the Earth has been accelerating for so many billions of years, has it reached the speed of light yet? Yeah, I think that's something the flat earthers would have to explain. Okay, and again, I want to distinguish the flat earthers from the plane earthers. The plane earthers have a totally different mechanism for gravity. They do it on the basis of density and um, what is it? Buoyancy. Okay, density and buoyancy. So here it is. I think this is theirs. Okay, this is not the flat Earth. This is the plane earthers. Okay, and I love their dome. The dome covers the Earth. Okay, there's a dome there. It looks cute. It really does. And you can see in the upper right, I circled their synthesis. That's all you get for their entire um, mechanism for gravity. The concept of gravity could be replaced by density and buoyancy. That is, everything that weighs more than air falls, and everything that weighs less floats. That's it. Okay, that you won't get anything else other than that. And the problem with this is that I think it's easily debunked. Okay, here you have one case. I built a little, I work with vacuum for many years, vacuum chambers, plasma. Um, and one of the things you'll notice is that vacuum, from a chamber, when you evacuate a chamber with pumps, um, you go from higher density to lower density. Things move in the opposite direction as buoyancy. And you have to explain that. See, here it is. When you talk about gravity, yeah, they can say, well, the denser objects or the heavier objects fall through denser medium, from light through rare medium to uh, uh, denser medium, right? But here you have the same situation sideways, not because of gravity, but because you're going from a chamber into a vacuum pump. In this case, I put a cryo pump, and this is just a schematic so that you can see you've got the particles in the chamber. They're going to be evacuated through that tube into the cryo pump. The cryo pump, the way it works, it just has a lot of crevices, and it's very cold. And so what it does, it freezes the particles into that crevice, and because it creates a ever fewer particles along that line there, along that tunnel, that's how you evacuate the chamber. The particles are moving from a higher density to a lower density. And so it's not true that buoyancy works at least in a vacuum chamber. So you cannot use their mechanism of gravity, what they plan to replace gravity with, because it wouldn't work sideways. Downwards, yeah, because of gravity. No kidding. But then explain it sideways, and they can't do that. See, that's the issue. And apparently, these people are ignorant. They've never worked with pumping systems or with vacuum chambers, so they have no experience with any of this. Okay. Now they might think that I'm misleading them, that I'm disinforming them because this. I'm part of the conspiracy. No, go ahead, go run your own vacuum. They even sell small kits of vacuum systems that they can prove it to themselves. They can go sideways so that they don't have to use gravity, and they'll find out that it moves from higher density to lower density. So anybody can prove that to themselves. The issue is, anyways, what's outside of that? Let me show it again. What's outside of this dome that they have there, right? Okay. And see, they say that you can only measure up to 10 to the minus 3, which is where the dome ends. And after that, we don't know what's up there because no one's ever been up there. It's a convenient argument because they're saying, okay, NASA never went to space. We have nothing in space, no satellites, no anything. And so we never went beyond the dome. Okay, that's the argument that they make. And so the first question is to a flat earther, right? To a plain earther, is have you ever been up there and measured 10 to the minus 3? Where did you get that number? See, the issue is they're very selective in what they believe and what they don't believe. They want to believe 10 to the minus 3, which was measured by the government and other people, and they don't want to accept the same readings of those same people above the dome. When you get into outer space and you measure up to 10 to the minus 11 torr, they don't accept those readings. So why accept the 10 to the minus 3? Has any of them been up there to measure, to see if, is the government also guarding the dome? All these soldiers guarding the dome? No, we got a problem because these people are very selective in how they use the information. They like the 10 to the minus 3, they like that part, but they don't like the 10 to the minus 11 because we've never been into space. So, they select whatever they want. Okay. What else do we have here? Yeah, okay. They say, well, how is it that humans don't fall out of space when if the Earth rotated, it's round and it rotates? Why don't humans fall off the space under the rope model, which is different than the establishment's model? Every atom in your body is connected to every atom on Earth. Therefore, you are essentially tied to the Earth. That's it. Okay? That's in a nutshell. You can look at the previous videos to find out more in detail what all that means. And just to rub it in, I'm just going to include this, that you have gases of different densities, like helium compared to CO2 or any other gas. Almost helium's the lightest one. If you put a little fly in there, do you think the fly would be sucked into the denser medium? Would it drift in that direction simply because of the density of the two gases? If you could let them both into a chamber, right? And at that specific moment where you release the gas, you have higher density on your right than on your left. Would the fly or the ant or any tiny thing move in the direction of the higher density? Absolutely not. That's the answer. So, all this is nonsense about the flat earthers, replacing gravity with density and buoyancy, as well as with the, dark energy that pushes up from below. Okay, so much for flat earthers. I don't think it's worth going more deeply into flat earth theory because they don't have, essentially, as someone pointed out, they don't have a theory. They don't have anything to propose. What they spend all day long talking about, go to any of their talk shows, they talk about conspiracy, conspiracy, and conspiracy. And that's politics. That's not science. Even if they were correct, okay? Even if they're correct, that's politics. That's religion. It's not science. Science is you got to explain. That's it. Okay. Okay. So what about these electric universers? Well, I think they're in pretty much the same boat as the flat earthers. I think they're just as irrational. So, Bill, what are you saying? You're treating us like the flat earthers? Well, pretty much. I mean, electric universe is right up there with the flat earthers when you come to think of it. So what am I going to talk about? Well, let me say up front what I'll be talking about so that you can follow along. Okay, these are the issues that I want to raise. If I can raise the little thing here. Okay, that's what I'd like to. These are the points that I want to make against the electric universe. These are the irrationalities of the electric universe. First one called the von Daniken-Velikovsky syndrome. Velikovsky was not exactly like von Daniken. I'll go over that in a minute, but the syndrome is more or less the same thing. Okay, they emphasize experiment, evidence, and proof when there is no room for any of those in science. That's religion. That's just trying to convince you. They're very weak on definitions, and I'm being very kind. They don't have any definitions. They don't have any rigorous definitions, specifically of those three terms. Those are the ones I'd like to cover: plasma, electricity, and instantaneous. Okay, because there's this debate between Walt Thornhill and a previous guy, Sainsbury, where they talk about whether gravity is instantaneous. Okay, and so when I get to the gravity part, I'll be discussing that as well. So yeah, plasma and electricity are two terms that underlie, you could say, 100% of the electric universe, and they don't have definitions for those two terms. I'll go over that in a minute. They have irrational assumptions. All their assumptions are irrational. The main one is that concerning the atom and the electron. Okay, essentially, in a nutshell, they borrowed Niels Bohr's planetary model. That's it. And the planetary model is irrational, and it's if I use Richard Feynman's terms, his how he stated it. He said, you know, um, we've given up on trying to understand how the universe works. So they're not going to give you a qualitative explanation. What they're going to give you instead is a quantitative description. Okay, and yeah, again, the atom, at least the quantum atom guys, they realize that their atom is a little more sophisticated than the little bee going around the nucleus, but apparently the people in the electric universe have never figured that out. and I'm going to go over that in a minute. Space is filled with plasma, according to the electric universe. Actual readings completely debunk that notion. Space is not filled with plasma, and that is going to be a point of contention. Okay, and then electric the electric universe believes that electromagnetism plays a role in orbital mechanics. In other words, they're replacing gravity with electricity. And part of that goes to that previous issue, whether there is a plasma serving as a mediator. That's an important point. So we need to know what plasma is. We need to know what electricity is. We don't know it from the electric universe because they never defined it. And they're going to use those to do gravity, to replace gravity. And then it turns out that the readings show that there is no plasma, even if that were the mechanism that, that they propose. They're starting out with an invalid assumption because there is no evidence, first, that there is a reading, okay, of say, high pressure or 10 to the minus 3 vacuum, okay, minus 3 torr vacuum, which is what you would need to run a current in space. And then, again, the same thing. Stars are powered by galactic electric currents. The idea the electric universe has is that all galaxies are somehow interconnected electrically, which means that also within each galaxy, all stars are connected electrically, which means that within each solar system, which in star system, the planets are tied electrically to their main star, their sun. Okay, and so there's no way. At least the readings we have out there don't back their assumption. Okay, so they can't start their theory because their assumption is irrational. It's calling black white. That's what they're doing. Okay. Okay, so let's get started. Let's go first with the von Daniken-Velikovsky syndrome. What is that? Well, for those of you who don't know him, von Daniken was a guy who said that the extraterrestrial, they came down to Earth and they did all these things in the past. They built the pyramids, all the pyramids, the ones for the Mayans and the Egyptians, all the pyramids, okay? So they did a lot of work here on Earth. Then they left. They forgot to leave a ray gun behind, So we can't prove it except, there's no evidence of any of that happening. So it's just all circumstantial things that these people are reading into the images left to us by the ancients. That's all it is. And that was von Daniken. Now, Immanuel Velikovsky, he was not really into that exactly, but he was into something similar, and which is what the electric universe is into. And that is that they say that a lot of these pictorials, these images left by our ancestors, the people of thousands of years ago, they point to a different universe that they had at that time. Okay, what was the different universe? Well, supposedly the structure of the solar system was a little different. Maybe the planets were closer together and there was more electricity going on. And that's how the gods came to be. These people were able to see the planets maybe closer to us. A lot of electricity going on, a lot of zapping. And they said, oh, that's Zeus. Oh, that's this other god, maybe Poseidon or whatever. And so they related, that's what these people say, that a lot of these religions started because our ancestors were seeing something different in the sky than what we see today. Now, for one thing we have to concede is that, today we live in the cities primarily, and most people just go to work, and very few people, I think, stare at the sky, with just their eyes and wonder and stay there looking, partly because most of the cities are clouded, they've got a lot of smog, and partly because people have other things on their minds. But in the old days, we can imagine, a lot of these sheep herders and so on at night just looking up on the sky, no smog, and they probably wondered, they had nothing else to do, they probably wondered about the stars. And my point is, they probably knew a little more about the night sky than most people know today, simply because we don't look at the night sky. Most of us don't, okay? There are people who look at it through their telescopes. There are others who have their private amateur telescopes. But if you look at the proportion of people today that do that kind of thing compared to what it was in the past, I think in the past we would say there was a higher percentage of people looking up in the night sky and wondering and coming up with stories with little tales. And what these people have done, the Electric Universe, is glorify those pictures, those stories, and made a mountain out of a molehill. They think that these people were so wise, they knew stuff that we don't know today. And that's essentially the von Daniken Velikovsky syndrome that I say, that to think that people who wrote the Bible, people who wrote the ancient books, the Bhagavad Gita, or any of those ancient books, that anyone that you want to mention, that they had more knowledge, more under not knowledge, they had more understanding of how nature works. They didn't. Believe me, they did not. They were wise in how to behave in society, that kind of thing, politics, religion, that social behavior. In that sense, they were very wise. They're just as wise or even wiser than we are today. That's a different story than saying that these people knew what light is, what electricity is, what plasma is, what any of that is. They had no idea whatsoever how Mother Nature does her tricks. And if you want proof, okay, I'll give you proof. You want evidence, I'll give you evidence. Go to any book and see if they talk about electricity, if they talk about light. All these modern scholars who do revisionism, they'll go into the books and say, see here, I found the word, I don't know, one guy told me they found the word rope. And supposedly these guys had discovered the rope. So if tomorrow's, the rope hits the jackpot, these people are going to say, see, our book always said that, the ropes of God. It's like they can interpret anything from their books. You don't go to any of these books to really understand how electricity works, how light works, how magnetism works. A lot of them didn't even know about the magnets. Okay, so no, or gravity for that matter. They had no idea about these things. So in that sense, they were completely ignorant. And to say that these people looked at the stars and knew, about all this electricity going on, in the night sky, is, I think, just overblown completely. Has no merit whatsoever. And so, both Wall Thornhill, David Talbot, they wrote a book about it, I think, the Thunderbolts of the Gods, in which they go over a lot of this stuff. And a lot of that resembles a lot of this flat earth kind of thinking, and also von Daniken type of thinking. These guys think in crop circles terms. This idea that there's something like supernatural in the sense that the people in the old days had a lot of knowledge that we lost over the years. And for sure, we can get rid of von Daniken as well. For those of you who believe that, the Martians came here, or the Klingons, or whatever, built the pyramids or whatever, or Roswell, it never happened. Never happened. Never could have happened. Under the rope model, it's impossible. Listen carefully, okay? It's impossible to do interstellar travel for any living entity. Okay, so this nonsense about panspermia, that some bugs, stowed away on a little asteroid and came to Earth, nonsense. 100% nonsense. Okay, none of it is out. There is no possibility of any living entity. Okay, no possibility whatsoever of any living entity being able to travel from one star to another star. I'm not going to go over that in detail. You can look at my video called Pioneer Anomaly, where I explain that in more or less detail, why you can't leave the solar system. Nothing living can leave the solar system. Okay, and just go to Pioneer Anomaly and you'll get a good perspective of what the rope model why the rope model forbids panspermia or interstellar travel in any way, shape, or form by a living entity. So, yeah, the Martians never came here. The Klingons never came here. And those guys that fell on Roswell must have been some drunks. It couldn't have been anyone from another planet. Okay. Okay, so let's continue here. The other thing they have is all these, as a result of that, they have all these mystic symbols in their book, and they talk about, the phenomenon in ancient times. Discovery of the electric universe does not change the picture of the heavens. It does not just, change the picture of the heavens. It also changes what we see and hear in messages from the ancient world. And they go on talking about, how these people left clues. And so what happens is, it gets to this point where they are putting all these signs and symbols that the people of the ancient days left us, okay, the days of old. They left us all these symbols, marked on stone and whatever that we find today. And they think these have some breathtaking meaning, okay, that a lot of this points to astronomical data and mathematics and all this other stuff. And they're not the only ones. A lot of people think that there's meaning in all this stuff. And was there meaning? Well, there was a meaning for the guys of old, obviously. These people put these signs because they put some symbol there. I mean, if we were to come go to the future and find or let's put it this way, let's assume the Martians come to Earth, right? And they found a million years from now, right? We're all dead. And they dig around, they find a swastika. Oh, they date it and they say, oh, this was from the 20th century. Well, did that tell us anything about, the stars? What are we supposed to interpret from that? If you find a symbol, you find the hammer and um, sickle. What are we supposed to interpret from that? Are we supposed to get some astronomical information from that? And I think the same thing happens here. These people are looking into stuff like saying, I'm going to get the knowledge, I'm going to try to understand the knowledge that the people of old had. It's more than ridiculous. That's what it is. Okay. There is no chance of saying that you're going to go into the past, even mentally, looking at some picture that someone a long time ago drew or carved or whatever, and that you're gonna from that try to interpret. Uh, Not that they probably drew the sun, yeah, that kind of thing. Yeah, they did, and they probably related to some god. There, no problem there. But to go beyond that and say, oh, they knew exactly how the solar system worked, and they had all this knowledge, that's where it just overblown. Okay. Okay, let's continue here. What's the other problem with the second problem we have? Let me put that back up here so we see it. Okay, following along here. The second problem is that these people emphasize experiment, evidence, and proof. Okay, um, and this is not only unique to them; it's unique to, not unique, but it's really ubiquitous. Everybody out there, the mainstream, flat earthers specifically, electric universe, all of these people harp on experiment, evidence, and proof. None of this has anything to do with science because, why do you do an experiment? Is it to corroborate a theory? Corroborate for whom? For yourself. You're trying to prove to yourself, right, that you can repeat something that you're thinking, your physical interpretation of something. That's what you're trying to do. And so, yeah, see here, let me just give an example here. These people harp on evidence, okay? And they are concerned about evidence. They're concerned about something that is testable. In other words, they want to use their hands, their eyes, their ears, whatever senses they have. They're all essentially senses of touch. And they say they're going to prove, but prove to whom? They're proving to themselves, and then they're using this. What is evidence? It's what the prosecutor presents to a jury to try to persuade the jury. He's trying to convince them. He's not showing something objectively. He's saying, look, here is an objective explanation, a mechanism. And now you look at the mechanism and you understand it because you're watching the mechanism. That's different than saying, I'm going to present proof. What is the proof for? It's proof. Proof means, or evidence. You're trying to prove to the jury that they should change their way of thinking and go along with your way of thinking. So, you're twisting their arms. You're trying to persuade. You're trying to convince, convert, and recruit. That's what all those elements are for. Okay, and yeah, those are things that the prosecutor uses to try to convince the jury, to sway the jury to his side of the case. That's all it is. Okay, and here's another bit of evidence. Okay, this is one that is popular with them. They'll show a picture of the universe, all lighted up like a Christmas tree, as Walt Thornhill said once. And then next to it, they show lightning, okay, here on Earth. And they say, see, there's evidence. That's proof. See, the sky is very much like, the night sky out there, the galaxy, are very much like our sky when we have thunder and we have the electric sky, during rains or whatever. Well, there's a little difference between these two images. The one on the left, the one of the universe, that's permanent. The one on the right is just what is known as arcing. It's just a one-shot deal. You don't see the sky lighted up continuously. It's Zeus sending his thunderbolt and just lighting up the sky momentarily, and then it turns off again. That's not what you see on the left side. So this is a bad analogy. It's an analogy. First, it's misplaced, and second, it's used to convince. It's just to try to convince you through the image that they're right, that their theory is correct. See, the sky is electrical. No. One thing has nothing to do with the other here. Okay, it doesn't mean that the sky is electrical and that you have a constant current flowing, in the night sky, because you don't have a constant current flowing in the rainy sky either. So to use the rainy sky, the thunder and lightning, as an analogy of what happens out there in the universe is very, very misleading. And again, they harp on this because they try to convince you through images rather than through arguments. That's the point. Okay. Where does this take us? Well, it takes us to understanding what science is about. What is science about? Because if science is about evidence, we have a problem. And, I won't be able to make my case in court against the electric universe if people believe that science is about presenting evidence, doing experiments, and proving stuff. That's not what science is. That's, has an atheist convinced a born-again Christian that God does not exist? Has it happened vice versa? The other way around, the Christian convince with all the evidence and proof, right? The atheist to believe in God? It rarely happens. So, it's not what we present as evidence that's going to win the case. What's going to win the case in science is understanding. You have to understand and not present evidence and say, look, I've got an experiment. I don't care about your experiment. I can do an experiment all day long. In fact, I do one every day. It's I let go of the pen and it falls to the floor or to my table. And I can do the experiment, repeatable experiment. I can do it 1,000,000 times. And I can observe it. I can study it. I can do all these things. Does it mean I understand gravity because I do all these things? Can I explain gravity? So there's a difference between studying, observing, doing experiments, repeatable experiments, whatever, etc., measuring, taking measurements, calculating. I can do all those things. It doesn't mean I'm going to understand what gravity is. And so, no, all those elements are not a part of science. That's why here it is, okay? We have to go through this painful process of showing people what science is not. Okay, we don't observe, we don't study, we don't analyze, we don't predict, we don't make predictions in science. That's not what science is about, making predictions. That's like betting on a horse or something. collect data? No, we can collect all the data all day long. That doesn't mean we're going to understand what we're doing. Do we do math and equations? Those are just descriptions, which is the next word, describe. We don't describe. What we do is explain, which is on the right-hand side. That's all we do in science. We do it objectively. Do we present evidence, do experiments? No. Do we demonstrate to someone? Yeah, you can demonstrate all you want. What we need is an explanation of a mechanism. That's what we need in physics, especially. Do we seek the truth? No, because we don't know what the truth is. What is truth to you is a lie to me. So we don't seek the truth. The only truth is the one that Mother Nature knows. All of us, we're all liars. Do we prove? No. Do we persuade, convince, convert, and recruit? No. Do we know or believe? No. Know and believe are synonyms, by the way. Knowledge is justified true belief. So knowledge and belief are the same thing. So no, we don't believe. We explain. We explain so that someone understands the mechanism we propose. What he believes or knows after that, that's his problem. That doesn't concern science. And of course, we don't win prize or censor theories. We don't do authority. Okay, that's mathematical physics. They work through authority. We don't vote for theories. Science is not democratic, and we don't testify or present witnesses. Okay, so if you do any of those activities, any of those, if you think science has anything to do with any of those, well, you're in the wrong place. You're not a physicist. You're not a scientist. You're a religious fanatic. That's all you are. So if you do any of those, if you say, well, prove to me, well, demonstrate to me, well, you're talking about religion. We don't prove. I explain to you a mechanism so that you understand. I make a movie of it. It's objective. You stare it. You reach your own conclusion. Whether you believe or not is your own problem. But for me to go in there and say, no, stay here. Let me show you some evidence. Now I'm trying to convince you. Now I'm trying to convert you. That's religion. That's not science anymore. Especially if you put authority and you say, well, all the mathematicians on Earth voted for my theory. Well, Mother Nature laughs at that. She doesn't care if everyone on Earth voted for the flat Earth theory. Okay? So no, none of those elements belong to science. Okay? And yeah, here you have the difference. And this is important also to note because, again, this goes a long way into showing the difference between the electric universe and science. Okay, electric universe, the scientific method is the same thing as the mainstream. That's where everybody has learned this in high school. And it's interesting that the electric universe, like the flat earthers, they criticize the establishment, but they got their notion of the scientific method from the establishment. Where did they learn that scientific method? Didn't they learn that in high school or in college? So that's where they got the so-called scientific method. And what do they want to use? Well, they want to use the senses. They want to say vision, hearing, smell, taste, touch. And the only real sense that they have to use is the least common of all senses, their brain. Their thinking. That's the common sense. And again, least common of all senses. You don't find it. It's very rare, very scarce here on Earth. Okay, what is genuine science? Rational explanations, objective explanation. You show me a movie of your mechanism, and I ask questions until I understand it. Not until I prove it, not until I demonstrate it, not until I criticize it. No, that's not the point. The point is to understand. That's the first step. And you can see if it's rational explanations, then the scientific method is different because now you have to find a way of explaining to someone in a rational manner that he can follow your presentation. That's the point of science, that I can explain a mechanism, especially the mechanisms that Mother Nature uses. What are the ones that we need to figure out? Well, the invisible stuff. I mean, if mathematics was part of science, right? If mathematics was the language of physics, today we would be able to explain how a magnet attracts another, how gravity works, what light is. We could explain all these things, electricity. We could explain it all. Today we have no explanations, no physical interpretations, no rational physical interpretations how all this works. And Richard Feynman, Nobel Prize, he was on top of all these things. He says, we've given up on that. We've given up on that. The theorists, the physicists, mathematical physicists, they've given up on that. They've given up on trying to understand how how Mother Nature runs her daily work shop. They've given up on that. They're not trying to explain it anymore. So if you're waiting and asking questions like in Quora, a lot of people ask qualitative questions. Well, they're spinning their wheels because they're never going to get an answer. We don't know after so many years, so many hundreds of years of mathematics, we still don't know those basic invisible mechanisms that Mother Nature uses. And those are the ones that we have to explain. We have to explain the invisible mechanisms of Mother Nature. That's all we have to do. Once we explain them, we're done with physics. We're finished with physics. There's no more physics after that because that's the only thing that's remaining. I mean, we have technology, we have math developed to ridiculous levels. I don't know if you're on top of this subject, but if you look at what the mathematicians are developing in terms of math, it's gone to ridiculous levels. These people are they're going into fractals and some, manifolds and some nonsense that has nothing at all to do with physics. It's also abstract and just equations over equations over equations. They've taken it to ridiculous limits. And we have all this ridiculous level of mathematics. We still cannot explain how a magnet attracts another. So clearly mathematics is not the language of physics if physics is explaining how Mother Nature runs her shop. That's the point. And the question is whether the electric universe is any better. And I'm saying it's not. And it's not in part because they're not following the scientific method. And, these people are way off the mark because they're still trying to prove, they're still trying to run experiments and saying, I need to run an experiment. We have to do this empirically. What are they trying to do? They're trying to use physical objects that we can see and touch to simulate the universe of Mother Nature, which is run by things that we cannot see and that we cannot touch. I mean, what is gravity? Can you see gravity, the mechanism, gravity, the mediator? Can you touch it? No, of course not. And so how are you going to simulate it in a lab? How can you go to the lab with something of our everyday life, whatever you want? I don't care what it is, okay? Can you go with that thing, that 3D thing, to the lab and simulate how Mother Nature does light, which you can't touch and see? I mean, the mediator, you see light, but you can't see the mediator of light. Gravity, magnetism, you can't see or touch any of these things, but you want to go to the lab to verify the theory. No, these are theories where you have to lay back, sit back, and try to visualize. That's the only way to approach them. And you got to make a movie of what you have in your mind, and that's what you give to others, and that's called science. An explanation, an objective explanation of how Mother Nature runs her shop. That's science, okay? And people who have a hard time believing that or understanding that, we give them the good treatment in rational science. Please try to understand before one of us dies. And we do it the Faulty Towers way, we just bang them with whatever we have on our hands, okay? For those of you who have watched my Neanderthal thing, this is what we do. We do the Kawabanga thing. Kawabanga. There we go. That's how we do it. And we just bang you over the head, okay? So just be aware of how we do these things, okay? We don't take nonsense from no one. Okay, so what do we do? Well, we explain. And sometimes there are different explanations for the same phenomena, okay? One case is you go to the theater or to the show and you see the magician on stage and he cuts the lady in half. And so now start the questions. One guy has one theory, the other guy has another theory. And here's a couple theories, okay, of how the trick could have been done. One guy says, well, I think there was only one girl in there and her butt was underneath the stage. Okay? And then the other guy says, no, look, there were two girls in there and what you were seeing, the head of one and the shoes of the other, he just cut in between. Okay, so these are two ways, two theories for the same trick. Okay. And so, and as far as I know, there's like 7 different ways, at least that I've heard of, that this trick can be done. So you can have 7 different theories, or at least 2, as you can see there. And so, how do you find out which one is the true one? The correct one. Well, in here on Earth, we can go look for the magician. Maybe at his next show, maybe he traveled to the east to Tokyo, and you go to Tokyo and you talk to him and you say, well, how did you do the trick? We just want to solve it. Tell us how you did it. Did you do it this way or did you do it that way? And he might tell you. Maybe he's kind and doesn't throw that, we magicians, can you keep a secret? Yeah, well, so can we. We don't tell anybody. And, but we can't do that with Mother Nature. We can't go to Mother Nature and say, Mother Nature, how do you do gravity? Because Joe here says you do it this way, I say you do it that way. How do you really do it? And, we can't do that. So we don't have proof. We don't have proof. You can present all the evidence you want. Proof is in the eye of the beholder. That's all it is. There is no such thing as proving how Mother Nature runs her shop, because there's no way to talk to Mother Nature for her to confirm our proposals. Okay? And then, of course, like for the magic trick, you have the irrational explanations, which I think you can, you can believe them if you want, but then you can call them irrational because they are totally bonkers. Like the mathematician, he'll go ahead and say, well, they observed, okay, and I predicted. And he says that the magician actually cut the lady in half. You say, huh? What are you saying? Yeah, he cut her in half. He sawed her in half. And so they take the magician to the judge. They're going to try him for murder. And a mathematician goes up there and said, no, Your Honor, this man is innocent. See what he did? He killed the girl here on this planet, but in another planet, in a parallel universe, the girl went shopping and had a baby, or maybe had her hair done. So they solve it with equations and with statistics, and she convinces the judge that in fact, the girl died in this universe, but not in another universe. And that's the kind of answers you get from the establishment. Okay, so there are irrational explanations, and they all come from the mathematical establishment. Okay. So moving on here. We have this is absolutely important to understand the criticism against the electric universe. If you're not in tune with this, well, you might as well tune off, because you won't understand a lot of the explanations that are going to be hurled against the electric universe. And the main one I want to point out to is that first word on the brown side, on the right side, the word something. The word something, that which has shape. Well, it takes 2 years, and sometimes not even that is enough. Sometimes they never learn it, for an electric universer, to understand what an object is. They simply have no idea what an object is, and they confuse objects with concepts. And what they do is, of course, they try to accuse you of raising semantic arguments. Oh, I came here to do physics. I don't want to do semantics, English. That's on the other side of campus. Here we do experiments, and we do everything empirically, and we do these flashy experiments where, we see flashy lights. And the issue is, can you explain that? And they say, well, yeah, I can explain it. Look, we take a little bit of energy here, plasma over there, and we mix it up with a little bit of charge. And so they think they're moving objects, that they're talking about objects, and they're talking all about concepts. And they don't realize this. And when you pin them against the ropes and tell them, look, you're moving love, you're kicking, data, you're waving intelligence. You can't do that in physics. And you're doing semantics. That's what they say. You're doing word games. And so, yeah, and one of the big problems is the word plasma that underlies completely the electric universe. If you can't get plasma right, well, you don't have a theory. And that's where it starts. Here we have the difference between a gas and plasma. And, an electric universe is a person who's never going to understand that plasma is not a physical object. He thinks he's dealing with something physical. And the word physical means something, and plasma is not a something. Plasma is something in motion. What you have to identify is what that something is, and not treat the movie as a static image. See, the one on the left, gas, is a static image, and the one on the right is not a static image. It's a movie. And if you can't tell the difference, well, you got to see an ophthalmologist, okay? There is a difference between those two. And so people say, well, Bill, gas also moves. And where is it? I got to do a kawabunga at that point, Kawabunga. There we go. Okay. Yeah, you got to be a total idiot not to understand that gas is. You can have any gas. It doesn't matter. And here, let me show you a couple gases that are static, that they don't move. We took a photograph of them. Okay. Here it goes. Okay. Here it is. Okay, here you have static image of gas, the one on the upper left and the one on the lower right. The lower right was taken by the space station. It's a picture of our atmosphere, okay, of the Earth's atmosphere, and that's the moon at the far end there. Okay, so that's a static picture of a gas. We call it atmosphere. It's got oxygen and who knows what else in there. And that whole bunch of molecules forms this layer that covers the Earth all around radially, okay? And then you have a more common gas, which is smoke, okay? Those are particles, and there you have it. It's a gas, okay? And I can take a picture of that, and I can show you the picture. All those gases don't have to be moving, okay? Now, if you compare it against the dynamic plasma, now we got a difference. Because now you see dynamic plasma, ionized argon, and dynamic plasma, ionized fluor, like in a fluorescent tube. And you say, see, Bill, I took a picture of argon, of ionized argon. I took a picture of ionized fluor, okay? Well, did you? Okay, you took a picture of something, right? What did you take a picture of? That's the question. See, in the other case, we don't have to have the clouds move or the air move. We can take a picture, and if it's not moving, if we took a cross section of time in the universe, we would still see that stuff, but we still would call it gas. Whatever that gas is, it's immaterial. I'm saying that gas is a static concept. On the other hand, the other guys, like for example, take the fluorescent tube here. This is what a fluorescent tube is doing. Supposedly you are ionizing the material that's in there, the gas that's in there. You are ionizing, and what you have is you have current running through it. What does that mean? It means that you have something moving in there constantly. If you stop moving something in there, you no longer have the ionization process. Everything recombines, and what you have is gas back again. So you have gas and you have ionization, in other words, plasma. Plasma is something in motion. You can't take a picture of plasma, because whatever you take a picture of is a cross section of a motion of something. And that's not plasma, because plasma is defined as something in motion. Here it is. In fact, it's defined by the same electric universe. Here it is, okay? Tells you what it is. What is a plasma? This comes from them, okay? Neither solid nor liquid nor gas, blah, 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 blah. And what you see is the words charged, collection of free moving particles, lost electrons, stripped electrons. All the words are verbs that define a plasma. So you cannot remove the verb from the word plasma, no matter what you do. So the issue here is that you have to identify what physical object is it that's moving within a plasma, okay? That's the issue. So the point here that I'm trying to make is that plasma is not a physical object. The physical object that the electric universe should identify is what is moving. And do they identify that? Well, they say it's the electron bead. They say that, like in the case of plasma, ionization, electricity, what's moving is the electron bead. In the case of ionization, the electron bead drifted or was taken away from its atom, the outer electron bead, right? And when you have this soup of electron beads and ions, right, running around, right, they're moving, they're not recombining, because as soon as you take the two electrodes away, boom, you have recombination. You no longer have plasma in there. The only way you get that plasma is putting the two, connections back in there. And now you have a plasma. You have something going on. You have separation. So what are you talking about? You're not talking about plasma. You're talking about electron bead and, just to make it simple, proton bowling ball. That's it. You have them separated. That's what plasma is. That's what people are saying when they say plasma. And then electricity is the flow of the electron bead, supposedly from atom to atom. In the case of quantum mechanics, they've revised that. Well, you don't need the atom anymore. You can do it just with electron beads. So it's the electron bead which we have to talk about, and not plasma. And that's the problem. People want to talk about plasma like if, plasma is this magical substance. There is no substance called plasma. The substance is the ion and the electron. That's the substance. That's the thing. Plasma is a process, and a process is not a standalone object. Here's an object for you, okay? Let me show you an object so that you understand the word object, because this is the problem. You don't understand the word object yet, okay? This is an object. Do you know what that object is? No, you don't care. Why is it an object? Because it has shape. It's the only object in the universe. That's all God decided to make, aside from himself, right? So that's all you see, an object. That's it. Is it a dependent object, like a halo to an angel, like a magnetic field to its magnet? No, because there is no other object it's dependent upon. All you see is a shape. It's the only object in the universe. Is it moving? No, because it can only move with respect to other objects. This is the way you present an object in physics. You cannot do this with plasma, okay? You cannot do this with plasma. You cannot show me a picture of plasma, because plasma is defined with verbs in it. It's ionized gas. And that ionized is important. Without the ionized, all you have is gas, okay? So you need that word ionized in there, and that means it's a movie. You cannot confuse a movie with a standalone object like this white blob there is, okay? That's an object for the purposes of physics. That's how you present an object in physics. If it's not static, if it's not without motion, if it's not dependent on some other object, like a magnetic field is dependent on the magnet, that sort of thing, or halo of an angel is dependent on the angel. Without the angel, all you have is a plate or a ring, maybe, whichever. But without the angel, that's not a halo. A halo is only when you have the holy man underneath it. So it's a dependent object. So the word halo is not a standalone object. The word ring is. And so it's important to get the language straight, because people get lost in language here. Okay, they get lost in translation kind of thing. Okay, where does this take us? Well, it takes us to the notion of plasma, electric universe, which is these two notions, because they have two notions. The first one is that they show that it's ionized gas, and they show it in motion. How do they show it? They show it with arrows. Okay, so you can see the arrow. What's the arrow indicating on the left-hand side there? It's indicating motion. That's why they put the arrows. Otherwise, they would just put the little circles. They would not put, they might even put the plus and negative, but in that case, they would suggest that it's an atom. In order for those two to really have positive and negative influence in the plasma, to be part of a plasma, they would have to be flowing around. They would not, the electron would not belong to its atom. Okay, so you would have ions and electrons separate, flying around in a soup in there. So yeah, the arrows are put in there because the electric universe understands that the plasma is something in motion. And then to make it worse, they say, well, plasma is a state of matter. That makes it even worse, because state of matter is just a category. So if plasma is a state of matter, for sure it's not a physical standalone object, because it's a category that has to do primarily with temperature and pressure. Okay? And so a solid is not a physical object. The word solid does not represent a physical object. You can say cube, you can say, I don't know, box, and that's a physical object, but solid is a category that's separate from liquid, gas, and plasma. So in this context, the word gas, for example, is not a physical object. The word gas is a standalone physical object only when you're referring to a blob of gas that's floating somewhere. You know, like the air around the earth. If you say that's a gas, then that is an object. That word gas in that context stands in lieu of a physical standalone object. If you use the word gas, like in this context, as a category of gases, you know, or I'm sorry, as a category within solids, liquids, and plasma, then it's not a standalone object. So you have to understand the context as well, because people get confused and they say, well, Bill, gas is also not an object. No, it is and it ain't, depending on the context. Okay, you got to keep the context in the field of view. You cannot change the context. If you're going to say there's a gas around the earth, that word it represents an object. If you say gas is different than liquids, then it's not an object. Okay, so the context is important. Plasma, if it's a state of matter, it's not an object. It's not a standalone, it's a category. The only possibility of plasma being a standalone object is if you can take a snapshot of it. But as soon as you take a snapshot of it, you don't have the motion, you don't have the ionization that is necessary to make plasma a physical object. And so these are key issues that people need to understand. It's not semantics, it's not ontology, none of that. They dismiss it. Well, I want to do physics. Yeah, we're doing physics. We're laying the foundations of physics so that you understand that you cannot use plasma as a physical object. You want to use a physical object, use the electron, use the ion, the little ball without its electron, fine. As long as it's a ball, we're going to accept it as an object. But you cannot say that plasma is an object, that plasma did this and plasma did that. You cannot move what's already in motion. That's the point. So the word plasma is key, and that's the first criticism against the electric universe. Anyways, I'm going to continue with this on Sunday. I'm going to go into the other criticisms. Let me show you what I'm going to be covering here. And once again, where is it? If I can find it. Here it is. I think it's this one. Okay, so that's what I'm going to be covering. I'm going to be covering the definition of electricity, instantaneous, and then the rational assumptions of the electric universe, specifically the atom. Okay, I want to show that space is not filled with plasma. Over and over, it's been demonstrated, proven through experiment, through measurement. And well, I'll go over that, all those details. And finally, that you can't do solar system with electricity. Absolutely not. Irrational, totally irrational. We'll see you, on Sunday. We'll see you then. Bye-bye.